First of all, I welcome all the participants to this webinar, an initiative taken by TCR Advanced to share knowledge through this approach, so that we can provide you the knowledge and information to ensure that our plants, including boilers, they all remain in a safe category. So my today's topic is remaining life assessment, RLA of boilers, a compliance or an opportunity. Now, this is something very important to understand because, we have been doing a lot of boiler RLAs in the country, outside the country. We feel that in India, this is seen by 95% of the people as compliance, and 5% people look at this as an opportunity. So I thought, let me talk on those lines and provide the viewpoint, and make sure that the regulatory authorities, they have asked us to do remaining life assessment, that is Indian Boiler Regulation Act. They have indicated that any boiler which is operating more than 400 degrees centigrade temperature needs to be subjected to RLA after 11 years of operation. And the boilers which are operating less than 400 degrees centigrade temperature, you can do RLA after 25 years of operation. And then, you can do re-RLA depending upon the condition, but normally 6 and 12 years are provided for re-RLA service. However, there are compulsive inspection which has to be done at every 2 years. And important point is that if we are able to give the proof of our condition of the boiler subject to certain conditions, the every 2 year the extension can be given for 1 year or 2 year, depending upon the ability at which we demonstrate that our boilers are safe. So having said this, I would like to indicate that we are in the field of failure investigation, remaining life assessment, fitness for service, and advanced NDT testing of industrial assets. Having said this, we have been doing a huge number of boiler RLA. This database of TCR Advanced is something which has given an overview in the industry, that how our industry function and how such a critical components like pressure vessels and which is working at a very onerous conditions, that is boiler, needs a proper life assessment approach, and considering that approach as an opportunity, how operation improvements and maintenance practice improvement we can do, that is something the goal. Unfortunately, the RLA is more on the condition and what is the remaining life. But what are the points which we learn for operational aspect, which is missing in the requirement? And I appeal all the people, those who are listening to this webinar, that this is a great opportunity to ensure that whether your boilers have been operated properly or not, rather than only looking at the cracks and the thickness loss. So this is something a new point which we would like to highlight to industry, how an operational interface is possible to identify through investigation and testing approach. So we can improve the reliability of the boiler through RLA approach. We all know that the profits are always linked to reliability. When your plants are not having problems, whatever time you operate, it turns out to be into profits. It is necessary to maintain units online to be profitable, which is equally true. So RLA basically is done to ensure that the safety in the forefront remains as a major aspect. And while you do RLA, you take the outages and then you improve the efficiency of the boiler through different measures also. So the efficiency and safety both are improved considering RLA as RLA. Then unplanned outages and extended turnarounds can have severe financial impact, which incidents also affect reputation and heavy safety consequences. So, people wants to avoid any untoward incidents, but these are important points, which can be taken as a benefit from the perfect RLA study. So having said this, we would like to indicate that the world has gathered knowledge, by learning from the different incident which has occurred. I've kept few incidents just to set the tone of this talk. When you have we all know that the Titanic ship failed, it struck with an iceberg and a brittle failure occurred. At that time, the engineering fraternity come to know that the materials become brittle at a low temperature. Similarly, tank failure, breach failure, high temperature pipeline failures, boiler explosions are something which has put all the regulations in the world. So those are the things which teaches the entire world about. And similarly, past incidents and records, which are something which we need to keep in our plant. These are the basis for the improvement. Now, whenever I go to do RLA of the boilers in different companies, nobody provides the past failure reports because everybody thinks that RLA is done because of the compulsion and not as an opportunity. See, when you engage any remaining life assessment agency, it is very important for you to give them all the information data where the boilers having a problem in the past, because failures are only thing on which the entire engineering judgment and assessments have been made for better product, better operation, and better learnings have been derived. So this is something which we need to understand, that when you do RLA, please provide all the necessary information. Hello? Can I request people to put on the mute? Okay. So thank you. Having said this, we are in the superhuman era where the humans are empowered with a lot of data analytics. Humans are empowered with artificial intelligence and digitalization. So if you look at the how the maintenance practices were done earlier, you can think that earlier, in the first generation, the components were taken under maintenance when there was a problem. After that, the second generation which came, which has provided the scheduled shutdown. For example, this is what is being followed in most of the part in our country, that we still have the second generation where every 2 years or 4 years or 3 years, 1 year, depending upon the regulations, we shut down our plant. And the third generation is the RBI, or that is risk-based inspection, we can say knowledge-based inspection, RBLM, RCM. So these are all next generation, which is now slowly coming into our country, where people are trying to prioritize the inspection in the component based on the damage mechanisms, and people can predict what kind of problems will come. So having said this, we need to have the database is the key factor. Now, if you feel that your boiler is having a unique problem, the same boiler in other company will not have problems, but in your company there will be problems. So you have a unique systems of operating every boiler, and in that conditions, the database of prior failure history becomes the important aspect. And if you have analyzed any failure by third party, that reports please provide to all the inspection agencies. Then what are the life limiting factors of boilers? If you see, the life limiting factor of the boilers are material defects, then fabrication practices, stress, then stress concentration and stress intensity. Temperature is a huge problem in boilers, because we know that the entire design of the boiler is done by the temperature exchange, basically heat exchange. And then when one fluid goes inside and comes out as a steam, that is water, the entire process is nothing but the temperature and pressure-wise balanced. Then you have naturally thermal and mechanical fatigue cycles, because there is a flow also and there is a temperature fluctuation also. Then there are corrosion concerns, and then you have improper maintenance and operation of inspection. These are also major aspects. Now, improper maintenance and operation aspect, we would like to correlate with the observed damages, because the database has increased so much in the industry that we can predict, okay, this is the issue, then we need to do this much improvement in operation. And hence, can I request to put your microphone on mute, sir? Yeah. So, when you have, so when we say that the basis of the life assessment is the problems which you have faced plus the present condition of your boiler. So, we provide a lot of importance on these failure samples from the same boiler, and we consider that the whatever tube failure occurs in the boiler, it is an effect and not the cause. So, when you identify the the effect is the root cause is lying somewhere else. So, minimizing or eliminating the failure of the tube in India, like the rest of the world, represent this significant opportunity. In fact, in today's time, we receive about 20 to 25 boiler tube failure samples a month, which clearly indicates that there is a huge gap, because I'm sure only 5% of tubes are coming to me, or maybe 2% of tubes are coming to me for investigation from the whole country. Having said this, there is a huge potential to prevent this. And our remaining life assessment is a great opportunity to address these issues while we identify the life assessment. According to EPRI, power generation through fossil fuel, it provides 3% of generation loss due to tube failure. So even India produces around 250 or 260 gigawatt of power. Suppose 3%, if you consider 10 gigawatt. Now 10 gigawatt is what? It may be the power generation requirement of a small country anywhere in the world. That much loss we do because of the only failure. So RLA provides a great opportunity to ensure that even if we can reduce by 1% or 1.5 percentage, we are doing a huge service to the country. Since I would like to mention here that the TCR Advance always believes in sharing the knowledge. And this is the book which has been published by American Society of Metal, that is Failure Investigation of Boiler Tubes. And this is where a lot of case studies and tube failure informations are given. So I recommend all the boiler people to go through this book, which will give you a lot of information on damage mechanisms. Now, when we talk about the damage mechanism, you have it is said that in a boiler there are 36 damage mechanisms which are operating. Now, boiler RLA guidelines provided. Can I request to put on the mute, sir? Yeah, thank you. So, there are 36 damage mechanisms which are applicable to boiler. In fact, for industry, there are more than 85 damage mechanisms, but boilers are operating into limited fluids, that is water, steam water mixture, and a steam, and the combustion. So,
sir, you're in mute mode. Sir, you're in mute mode.
Okay, let me check. Okay. Am I audible now?
Yes, sir.
Yeah. So, if you look at I will just repeat this sentence in the slide, that there are 36 damage mechanisms which are applicable to boilers. And, as I told you that, it starts with the water. When water enters to the boiler, it enters through the preheater, and then from preheater, it goes to economizer. From economizer, it goes to water walls, and water walls to it goes to steam drum. From steam drum, the steam is separated, and then from separated steam, it goes to superheater. And then it goes to the end use, whether you are using it for power generation, or you are using it for utility, or you are using it for process input. So depending upon the application, there are different damages which occur, which is basically a fluid side corrosion. When you have oxygen is something which is we always controlled, but ask those guys, those who have recently have problems with the oxygen ingress accidentally, and the boiler tube failures occurs repetitively. So it is something very critical, oxygen pitting. Then you have under deposit corrosion in the water wall tube. Sometimes corrosion also occurs during acid cleaning, so you have to be very careful. Then, internal deposits and corrosion product buildup occurs either because of the exfoliating scale, or maybe because Uh, maybe because fireside waste, maybe because of the accumulation of the deposits over the time. So then you have a fireside wastage where oxidation problem occurs, hot corrosion occurs, fly ash erosion, fly ash corrosion, then soot blower erosion, particle. We all names which we all know. Then there are rupture kind of failures, which is a short term and a long term failure, which are not mostly occurred because of the operational issues. And then you have the graphitization and a sigma phase embrittlement. Now, these are graphitization problems I have seen in boilers in many locations where carbon steel is supposed to be operated less than 400 degrees centigrade as a skin temperature. But if your skin temperature increases to 425 plus, then the carbon steel subject to problem called graphitization, and it can really do a brittle fracture of the component. Then sigma phase embrittlement, they are quite common in stainless steel components. In the recent past, a lot of use of stainless steel materials are there in the boiler industry, where when they are operating in the range of 550 and plus skin temperature, the sigma phase forms, which reduces corrosion resistance and increases brittleness. Then you have fatigue. Fatigue is a very serious damage. Well, then a lot of components occur, and stress corrosion cracking and stress assisted cracking. Now, when I say, while RLA, we don't go for all these brainstorming. We do RLA only based on the guideline provided by Indian Boiler Regulation Act. But when you consider these as an opportunity, you must discuss the service provider and ask him to identify the damages in your boiler. That out of all these 36 damages, which damage will occur at which location? And people are trying to restrict the scope based on only those tables which are provided in the RLA assessment, rather than we should increase the scope while we take a shutdown and identify the issues which could be the potential problems in the future. So, these opportunity, very few people are using in the industry. And my appeal to all boiler users, because, we are facing a lot of problems of the failures, these are the opportunity to identify which damage will occur at which location. You can take the help of TCR. We can identify and make a complete offline study that, when such a failure will occur in your boiler, and we can provide you the entire area which will be investigated during RLA. So you can make two-part RLA. One is RLA as per the statutory guidelines, and one RLA for the life extension and for the for preventive maintenance or predictive maintenance. You can do. So this is something which we all need to convert this into an opportunity. And imagine if you are able to save even 1 day of shutdown of the boiler, the entire cost of the doing this study and everything is compensated in only in 1/4 of the savings which you make. Unfortunately, that saving is not recordable, because when the boiler operates without any problems, people don't consider that what has gone behind it. But it is time, because we can definitely identify when there are failures are occurring, when failures are reducing, the right amount, right kind of RLA done. One is offline and one RLA is done online. One, if it is done properly, I'm sure lot of improvements can be made. Now, this is a very important aspect. You need to understand the 4 parameters to understand the entire boiler. One is basically stress. The design of the entire boiler is done based on stress. The other one is temperature. The other one is corrosion, and for which you do all water treatment and sir, can you put the person who's talking on phone, can you put your on a mute, sir, so that so when you have corrosion in the boiler has been many forms. In water valve, it will occur differently. In economizer, it will occur differently. In the same water in the steam drum will behave differently. So, there are different forms of corrosion which you need to understand. And then wear. Wear can be, erosion aspect, which can be done from the flue gas side, or the erosion also can occur from the inside of the water and steam side, where the fluids are not controlled. Uncontrolled fluids can do a lot of wear and tear. So, these four basic mechanism derives all these 36 damage mechanism. So, identifying them, be considering the operational aspect, that is stress comes from the operation, plus the temperature comes from the operation. So these two aspects, and corrosion also can be controlled through operation. Wear can be controlled through operation. So it is very important to understand this interface between damages and operation. And that is where the life of the boiler can be improved. Now, there's a typical bathtub curve when you can see the in an early failure period, when the plant is new or a boiler is new, you will have a teething problem. A lot of failure will occur. So frequency of the failure will be high. So over the time it reduces, and then there is an intrinsic period where the failures are stagnant. Maybe sporadic failure will occur, and then again the frequency increases. So here when the problem occurs, people change the panels, people change the tubes. But when you do this in a preventive mode, when you are in an intrinsic mode, and when you do RLA, if you can identify what will occur at this time, you can extend this length up to this. So the life of the boiler can be extended by considering this as an opportunity. Now, the other aspect which I wanted to highlight this talk is the concept of magnetite layer. We all know that in the hot water above 80 degree or 100 degree, when it comes in contact with iron or steam, it forms the magnetite layer, that is Fe3O4, and it liberates hydrogen. Basically, it's a corrosion reaction which occurs for a very brief period of time, where this magnetite layer further protects the corrosion. Now, this magnetite layer, it is important to understand. In India, we have not looked inside the magnetite layer. I'm very keen to do the characterization of this scale, which has started being done with major one or two industries in the country, but we are not characterized this scale in general. So this scale gives you all the information, like blood reports gives the history of the persons and its lifestyle and behavior. Same thing, if the oxide layers are properly analyzed, it can tell you how your boiler were operated properly or not. Even if I ask you that the boilers can be only 20 to 30 microns are needed to protect the corrosion. Most of the time we operate our boilers above 100 microns, maybe 100 and 150 microns. In fact, 200 microns is considered to be normal. Now, believe me, when you increase the thickness of the magnetite layer, and then it also gets the extra 1 or 2% of the fuel, because it ultimately has to do heat exchange through these layers. So it's important that we keep them in check. We make sure that they remain intact without problems. Having said this, identification of the magnetite layer must be the part of life assessment, and especially after every 2 years or 4 years, when you take a shutdown, tubes to be removed, not only for RLA. These tubes are the great opportunity to find out the characterization. And now I'm very happy to say that TCR has started these services, and you can ask that how we can correlate our operation through this magnetite layer. And we will be able to give you insights to your operations through this magnetite layer. And this awareness needs to be improved, because we have been operating our plants based on the past experience. Now, with the new technology, it is important that we add this dimension also. So this is the examples how thick scales, sometimes when we analyze the boiler tube failures, we observe about 400, 500 micron thickness of the scale. Now this is insane, because it gives you 3 to 4% of extra burning. So whenever in your plant, if the average burning rate increases, it is important that we remove the tubes from certain sample size. If the operational or combustion is okay, then you further need to put more fuel. Then it's important to analyze the tubes from certain locations. So, and it also reduces the life of the tube. It is said that when you have tubes are operating more than 10 degree than the design temperature, that is skin temperature, the creep life reduces to 1/10. Now these increase in temperature further increases the scale thickness, It also increases the skin temperature, and the tube life is drastically reduced. So, long-term overheating will occur and a creep failure will occur. So, operation has a lot of bearing on the damages and the life of the boiler, which we observe. Now, this is a typical photograph of a scale, which shows a very undesirable scale, where you can see there are gaps, there are porosities, there are cracks in the layer. Now, these layers, instead of protecting, they are when there are gaps, it hampers the heat transfer, because you all know that the gap increases. So this is something which we need to look at very, very carefully. And very intact layer, the layer which is shown at the bottom most, very intact layer has to be formed of the boiler. Now, the theory in the subcritical boiler is different, and theory in the supercritical boiler is different. See, supercritical boilers are designed or they are mostly designed for once through, which means there is no stream drum in the supercritical boiler. In supercritical boiler, the material used in the most of the tubes are very high grade material. So there, instead of magnetite layer, you will form the chromia layer. Chromia is a chromium rich oxide layer. So these must be analyzed only on electron microscope. And it is said that any thickness above 40 microns or 50 microns reduces the efficiency of the boiler drastically. So, characterization of these layers are very, very important. We should know that our water treatments in the past were effective, and how we can improve the intactness of the layer, because this layer is dynamic. Any disturbance in water chemistry, any disturbance in temperature conditions will disturb this layer, and ultimately it will result into the failure, which is an effect and not the cause. So identification of damage can be a tip of an iceberg. There are primary and secondary failures. It is very important that when you do RLA of your boilers, we sometimes ignore condensers, because when you have problems in the water wall tubes, the condenser leakages are responsible for the water wall damages. So when you do RLA of the boilers, it is important to understand the past failures and do the testing. I recommend many times that whatever is your time constraint, the best way to identify condenser leakages is through helium leak test. Helium leak tests are by gold standard, because the micron levels of the leakages can be identified with them. And then minor additions of the water, it won't be even catch in your conductivity measurements people do of the condensate. So the disturbance, so whenever there are problems, it gives you indications where the problem will occur, and those needs to be considered during remaining life assessment. So what are the need for understanding RLA, rather than looking at as the compulsion that the party is capable of doing NDT at these locations. We want to understand that most of the standards and codes are based on likelihood of the failure and not the consequences of the failure. What is likelihood? Likelihood has been derived based on the past experience only. So consequences of the failures are economic consequences, and the other is the safety consequences. So both has to be put into consideration. For example, if I have to take a shutdown of my boiler, if the boiler tube fails, then my 4 days of production goes, or 3 days of production is gone. Then I will rather invest that money into preventing one tube failure. So my inspection during shutdown will be much more stringent to ensure that what failures how can I can avoid through operational improvements. Now operation people, if they are not bought into the damage mechanisms, they will never understand the importance of the failure, and hence this kind of study has to be done as the team. So before RLA is taken, a team needs to be formed between maintenance and operation, and then discussed with the RLA service provider agency. And then you can make a wonderful approach. Now basically the idea is to spend the resources at the right location. Support this team study identify that I have to do the hydrogen attack checking in the water wall tubes, which is not at all a requirement in IBR. Then you can include then in RLA. So, it provides a formal justification to extend plant run length time also. It provides the basis of the optimizing each inspection interval. You can reduce the inspection or you can increase the inspection based on this study. So, it's important that, before we take the RLA, we can take the complete detailed study here. So having said this, what are the steps for remaining life assessment? They are collection of background data and history of the boiler operation, which normally people are not providing. Understanding the actual degradation mechanism, which no people gives any time, because whenever the orders are given only 8 to 10 days before RLA in most of the cases, not all, and then people are in a hurry to complete the job. Through visual examination by a thorough visual examination by an expert is a compulsory requirement. Dimensional measurement of critical locations, collection of scale and deposit of samples and its analysis, detailed thickness survey and mapping, internal oxide scale measurement, which is also important, as I told you, WFMPI of the weld joints, in situ metallography, then in situ hardness, then suggestions on immediate repairing and calculation and judgment on repairing of life assessment analysis. This is basically the steps of RLA. Now, these can be, if these is followed by considering these as an opportunity, the entire exercise will give a great fruitful thing. Now, I want everyone to understand that, people think that we have done NDT, which means you have you are certifying the component, but it is important that every NDT has a limitation. For example, dye penetration testing, which we know that, but it is only possible on surface. Bulk the defects cannot be identified. MPI is only surface and up to 2 mm. UT is most material, but it is most important is can be operator dependent and prone to defect sizing error. Now, this is something which but I am very happy to say that in India, our inspection departments all over the country has gained a lot of knowledge. So, UT people are, UT, I consider it to be done in a right manner. Radiography, there is an issue where, most of the time the works are done at night, but, different orientation and size limitations are something which again a problem. ECT is again an operator dependent. Potential drop again is a limited accuracy and reliability is less. Replication is highly operator dependent and independent interpretation expertise. Now, this is something very important to understand, that most of the people, they come with the replica testing. I recommend people to take their interviews, because it's important. This is most important. Based on these, the life assessments are made. I'm disturbed to see that when I reviewed the report in the past, people have written the wrong interpretation in the report itself, and the photograph were taken not from the right components because it was not matching with the material. So, this is something which we need to understand as a owner of the equipment, that, whatever people are coming, you must interview to do the perfect RLA. So, basically you can identify as per category. American Petroleum Institute has given a good guideline. We can take a leaf out of their book for our boilers, that is it our inspection methods are highly effective, usually effective, fairly effective, poorly effective, or ineffective. When you start questioning this to your methods, this will give you a great fair idea that how do you improve the assessments through inspection. But there are certain damage mechanisms which need to understand, that in remaining life assessment in boiler, creep damage occurs in superheater, superheaders, reheater header, desuperheater nozzle, steam lines, and thermal fatigue will occur in almost all the components. Hydrogen embrittlement will occur in water wall tubes. Erosion will occur, corrosion will occur at the water circuit area. So, basically, the methodology depends on, how the damage will come to know. When you have a creep, most of the time I have found out that some choking is there in the header, or, the secondary combustion is occurring in the boiler. But it is seen by, swelling of the tube, diameters are increased. So, you can do certain NDT techniques. For fatigue, you have to do all the NDTs which are possible to identify the crack. Corrosion fatigue, locations needs to be identified based on the history of the failure. Then, you have a corrosion related failures. high temperature corrosion and thickness loss. So, you have to do measurements of the thickness. But thickness measurement is not the only answer to all your problems. So, consider it as the defense mechanism tool rather than certifying the boiler. So when I say defense mechanism tool means you have to do thickness concentrating more in the area where chances of thickness reduction are more. So there are different data which will come out as a study of RLA. So what is corrosion? Corrosion is the gradual degradation of the material due to chemical reaction with the environment, such as oxidation, sulfidation, boiler tubes. It happens in the boiler tubes. So basically, overall thickness loss occur. But what about the loss of thickness which occur localized? This is very dangerous. So it also calls that corrosion. So design is done for this general corrosion and not localized corrosion. So this is something, the data interpretation which we need to understand. And, extensive thickness survey is the only answer to identify this issue. Then, for identifying corrosion, you can have the boroscopic analysis, videoscopic analysis. I am extremely proud to say that DCR has more than 16 boroscope equipment. We supply to many industries. It also not only corrosion, but it can help you in many, many aspects. For boiler RLA, we conduct this in the header to identify whether any objects are there or not. So it can affect. Now, the other technique is the oxide scale thickness measurement, where non-destructively it is possible to measure the oxides in the boiler tubes. So when you measure the oxide scale, the limitation of this technique is that it cannot detect less than 100 micron, maybe 120 micron and less it cannot detect. But most of the time I have seen that the scale thicknesses are much higher than 120, and this is extremely useful tool which we deploy in the RLA. And, we have such 6 equipment. So, we supply it for a lot of services. Then, fatigue data. So fatigue occurs when, load cycle changes. And in today's time, you all know that because of the renewable energy sources has come, the lot of fluctuation is in demand for the power plants. So they are operating the boilers at a different load. And trust me, I am started getting a lot of failures because of the corrosion fatigue, because of the stress assisted cracking, because of the flow accelerated corrosion. These are the issues, are the side effects of the boiler tubes. So once we know that this kind of failure started occurring, we can devise in such a way, and if RLA is coinciding, we can do a thorough analysis, and we can identify and replace those areas which can create problems. So use the RLA as an opportunity. That's the message which I want to give through this talk. Then, we have advanced technique like time of flight correction, where the thicker welds are there. We can identify, this is very sensitive technique. And when it came, it was told that it will replace the radiography. But today, now it is used quite extensively in many cases where, you can do the testing in a daytime where other works are not hampered. Then, we have the other technique called phased array ultrasonic testing. Now, this is quite useful in identifying the issues with the tube-to-tube weld joints. PAUT, we have the bracelet probe, and these bracelet probes are put around the weld joint, and the entire joint can be configured. And TCR has identified at many companies. Unfortunately, the testing is considered as a labor job these days. So we lose a lot of jobs because of those aspects. But whenever there is a problem, people don't worry about the charges, and they call on us. We have all standard samples available with us, which can identify through phased array ultrasonic testing. Then you have a low frequency eddy current testing, which is also used in the boiler tubes assessment. Then you have HTHA problem. Now, I'm extremely happy to tell you that TCR Advance has developed the methods to identify the early detection of high temperature hydrogen attack from the boiler tubes. Now, once in 10 years, I recommend all the boilers to check for HTHA initiation, because when it happens in a very serious manner. So in RLA, I recommend this to be included. At least the certain sampling areas has to be done at least for 3 to 4 days study to be done on water wall tubes with high temperature hydrogen attack damage. And then, the base and the heart of the entire boiler study is nothing but to find out the creep damage, because the boiler life assessment, boiler is designed for, say, lakh hours. For that is as per the design information. But the boiler can run for more than 50, 60 years because you never touch the design parameters and run the boiler for that much time. And also, if the material and workmanship is good, you can extend the life. So creep is nothing but the slow deformation of the material used at under high temperature and pressure over time. And creep damage is common concern, particularly in the high temperature zones. So, you can measure the creep by diameter. You can do in situ metallography is the major area. In fact, the IBR also depends on the in situ metallography. And, you can identify the actual aspect. Now, here I want to tell you that, for composition, which are having two chrome material, and below when the first creep cavity occurs, we can say that the 40 to 50% life is expenditured. But if you have the 9 chrome material, very few information is available on this alloy. When the first creep cavity comes, the 70% of the life is consumed. So, it depends on the agencies with which you get the life assessment done is very, very important in this aspect. Then, there are these in situ metallography photograph where intact microstructure is kept and degraded structure is kept. We can estimate the temperature on the microstructure also. This is an electron microscopy image where black spot on the right side of the image shows the creep cavities and damage. These are the charts. You can identify the microstructure and temperature control. So, when you do periodic metallography to your plants, you can find out whether they are operated in a right manner or not. And then, very important aspect is that you have to check all the parameters of pressure and temperature trends in the past, which I think no RLA agency is doing it, or people have no knowledge to do it. So this is something which gives you a lot of information. These kind of studies needs to be done before RLA work. And then, you can decide the integrity operating window, where, you can identify the temperature window, pressure window, and also you can put restriction on combustions, impurities, and water treatment limits. So, when you do this with this window with AI technology, you can start the trigger. In fact, once you do that, the entire RLA has to be provided with proper recommendation, with immediate replacement of the components if any repair is needed, change in steam parameters at the inlet if required, alteration in the mode of future operation aspect, alteration in the material of certain components, need for more frequent inspection to monitor the damages. Deliverables will be on as is to be in the design conditions. This is something very, very important. And, once you do the effective utilization of NDT is the opportunity which we should do. So our prime objective is to help companies to achieve overall integrity, reliability, safety, optimization, and maintenance excellence. So in order to do that, TCR has come out with the asset integrity optimization and management tool. That this is not only for boilers, but boiler can be a part of this. And you can characterize the different damages, different inspection techniques, and then you can monitor the entire aspect with a lot of benefits, which is done with the use of AI and digital technology. So you can find out the different parameters and analytics so that you can take the right decisions. So having said this, when we have gathered so much of knowledge with our book by American Society of Metal, the world over people gave excellent reference to this book, and American Society of Metal has asked us to change the chapter on the boiler failures in the handbook of ASM. Now, handbook of ASM is something, this is in the name of TCR Advance, and I'm extremely proud to say that the whole world is using these as a reference to avoid problems. So with these words, I want to thank you everyone for joining and, giving this opportunity to share our knowledge. And, for any further inquiries, you can contact us. We can help you out in improving the life of your boilers. Use the IBR guidelines as an opportunity, and do very intense RLA